Hey, it's been a while since I've uploaded anything to my channel, so I wasn't going to do like a full-fledged video today, but just like a little tip, trick kind of thing, hopefully, shorter than 5 minutes. And today I want to talk about really, really crappy capacitors. You may hear that, capacitors, these things, especially electrolytic capacitors, are the things that go bad most often, and generally that's actually that is actually the case, but only with really badly made capacitors. If you look at something like extremely vintage, made in the USA, electrolytic capacitors aren't actually typically that prone to failing. It's really other types. But again, I'm not like fixing like incredibly vintage stuff. The stuff I look at is perhaps 30, 20 years old, and that's just when we started, the USA started importing these really crappy Taiwanese, Chinese capacitors, in the capacitor plague era and stuff like that. And so you'll find, not always, but typically, if stuff hasn't been powered on in a long time, these capacitors are really prone to failing, especially in power supplies. So I'm over here repairing or recapping this power supply that's like 20 years old, literally is from the year 2000. And so I'm finding a bunch of these Teapo caps that I've had bad experience with. They're all bulged and leaky. These types, I don't know how you pronounce that, Fuhjyyu or something, the really crappy type. I have some more in my bad cap bin. There's like these really crappy old capacitors. There's some that are bulged. In fact, like I think this one was like shorted. It's the same brand. As you can see, it's bulged on the top. It tests like a diode actually, and it's kind of weird. But yeah, these are just the worst of the worst. And so when you replace those, most people know about checking for capacitance. So like for instance, if you're using a multimeter that could check capacitance, and here is my known good cap for my parts bin. Should see 109 microfarads, if you could see that. And then we have our worse capacitor with the really short leads that it's hard to measure. Yeah, there we go, 113 microfarads. So not too bad, not too different, a little bit high capacitance actually. So these are both within spec for their capacitance, but as you probably know if you repair stuff, capacitance isn't the only thing you have to worry about. You also have to check the capacitor's ESR if it's an electrolytic capacitor. That is the equivalent series resistance, or the basically the felt impedance of the capacitor when it's being used to filter ripple current. And this also depends on the frequency of the test. So obviously, the best case scenario would be to test the ESR with a frequency that the power supply uses on the output, basically some number of kilohertz to test these things. Or you look at the manufacturer's datasheet, and if the datasheet specifies that the ESR was tested under 120 hertz, you would obviously use 120 hertz to test the ESR. And you can test ESR with an oscilloscope or with other tools. There are a bunch of methods for doing it. Or you can buy an ESR meter, or even one of these cheap component testers from China that also seem to do the trick. I don't really know the frequency of what they test the ESR, but I'm assuming it's like 1 kilohertz or maybe 10 kilohertz, 100 kilohertz, something like that. So this is the known good cap, and it's like 0.66 ohms, exactly the amount of capacitance, 100 microfarad, and 3% voltage loss. So then we look at this capacitor over here. Clip onto that, and of course these leads will add some resistance to it. So if you want to get a really accurate measurement, you put it right down on the socket. But we'll see here with this terrible brand It's about 1.1 ohms, which is not unreasonable. If I look at my ESR chart, it's about at the limit. And actually, to be frank and honest with you, it actually wasn't testing at 1.1 ohms before. It's actually testing close to the other one. So something must have happened. So we can go ahead and see. Maybe, hopefully, it won't do that again. Nope. So, well, it's a little bit high. ESR. Voltage loss is 4%. So that is quite interesting. But one of the tests that people don't usually know about, so people usually know about how to test capacitance, how to test ESR, but one of the tests that people sometimes forget about that is also kind of important on power supplies is leakage current. What is the DC leakage current of these capacitors? So if we go ahead over here and look at this, I have the data sheet here for the particular terrible capacitor I'm using. So if I can get this from this brand here, it's the TN series from Fuhjyyu. I just don't know how to pronounce that. I feel bad every time I have to pronounce that. And so these are generally considered one of the worst brand of caps, especially the ones that were made during the capacitor plague where they used the faulty electrolyte formula. And these are definitely those, I can tell. And so leakage current on the data sheet is specified by either 3 microamps or 0.01 times the capacitance times the testing voltage, basically. And whichever one of those is greater, that's basically what the leakage current is. So if I go ahead and do that, we should see that the leakage current is 0.01 times, I'm going to test it at 12 volts. It's a 16 volt capacitor, so 12 is probably all right. And times 0.0001 for 100 microfarads. And yes, we get about 12, yes, 12 microamps of a leakage current. So 12 is obviously greater than 3, so our max amount of leakage current should be 12. And now if we come over here to the test, how to test leakage current is pretty easy, actually. I have to go get my meter and set this up again. So I'm going to look at the output voltage on this meter. And basically I'm going to test the good capacitor first. So here's the here's what should be the output voltage there, and I can get a better view of this. And I have 12 volts dialed. Actually, I have 10 volts dialed. Now I have 12 volts dialed into the power supply. And so we're going to put the, basically we're just going to put this right across the power supply, minding the polarity in the breadboard there. And I have the current meter, which is the Simpson, hooked up here. So if we go ahead and give this a shot. Yes. So we can see that the Simpson went up and then went back down. So basically it charged and then came up to full voltage, basically. So we can go to the 1 milliamp scale, and we can see that basically it's still on 0. And if I wanted to, I could go to the 50 microamp scale, but basically there is no leakage through that capacitor. It's fully charged, it's not leaking any current, it's not self-discharging and requiring more current to keep the charge up. It is basically at 0. Alright, and then we can also go ahead and see it discharge. If I turn off the power supply, it discharges like that. So now we're going to try the bad capacitor, the one that tests a little bit high ESR. Although I should mention that the limit for ESR, according to this chart on the wall, is 1.6 ohms for 100 microfarad 16 volt. So it's not quite, it's definitely much higher than the good capacitor, but it's not terrible. So I'm going to put that one on there, minding polarity. Alright, and turn on the 12 volt power supply again. We can see that it charges. And now our voltage is indeed at 12 volts. So we can go ahead and go to the 1 milliamp scale. And we can see that this thing is leaking 400, 500, that would be 500 microamps there. So over 500 microamps of leakage, basically. Because we're on the 1 milliamp scale, so that's a milliamp, that's 0. So yeah, that would be 500 microamps. And if you remember what we were supposed to get, it was about 12 microamps. So yeah, I'd say that thing is a little bit leaky. And as you can see, it's going back down because the capacitor is reforming. Basically, if I kept that on there, we probably could get it to reform all the way, but then it would probably, go back up the next time I tried to use it. So that's too high leakage really to be acceptable in something like this. That won't filter out a lot of stuff. So, but yes, it is dropping back down. So there's that. But yes, thanks for watching. This has basically been how to 3 ways to test capacitors: capacitance, ESR, and DC leakage. So thanks for watching.